Hi, this is Wang, and today we are going to talk about the graphology. Um, the input is edges, which indicates there is an undirected edge between the node AI and BI in the graph, and we should return true um, if the edges of the given graph make up a validity, and false otherwise. So let's go through the two examples quickly. And for example one, it will be a validity. And for example two, um, it's a it's a return false. It's a return false. So compare these two graphs, we can just think about what's the difference between these two. And it's intuitive that we change these problems into checking whether there's a loop or the cycles in the graph. So the next question is why I use the BFS to solve these problems. Um, my logic is that during the BFS process, we if we pop the node from the queue and we go through its neighbors, and the node that pop from the queue will be the parent of all their neighbors. And if we find that the neighbors can find a way to go back to its parent without its original undirected edges between the parent and their neighbors, which means that, for example, here, 1, 2, 3, and 1 is a parent of the node 3, and 3 can find a path which is from the 2 and go back to 1. And so which means that there is a loop, so we should return false. Otherwise, we should return true. And here, we should know the parent node of some node. So we can use a hash map to store the information of that. And also, we should keep track which nodes we are already visited. So let's code it up. And visited should be a set. Because we can just start from any node in the graph. So we can just start from the 0 for convenience. Every time we just pop the corner node from the queue, and we go its chart for better explanations. Oh, forgot to build up the graph. Sorry about that. Because this is undirected, so we build up two edges between two nodes. So here we should be careful about. Um, if we found that the current node's parents is already in the list, if not, we just return -1 because the node is from the 0 to n -1, so there is no possibility that it will be -1. So if the current parent is equal to chart, which means just like 1 to 1 to 3 and 3 to 1, we'll just continue this process. And if it's not in that case, and the current the child is invisible, which means that we find the cycles in the loop in the graph. We can just return false. and we forgot about to add it to our parent. Otherwise, the parent of the child should be the current node, and give the child to our queue. And we should pay attention that there's a corner cases if the graph that based on edges contains two subgraphs. This will not work out, and it's not a valid tree. So if len visited is not equal to the n, we should return false. And otherwise, we just return true. Let's check. This seems to work. Yeah, that's pretty much about these problems. Thanks for watching.